Welcome back to AlgoJS. Today's question is LeetCode 191, number of 1 bits. So write a function that takes an unsigned integer and returns the number of 1 bits it has, also known as the Hamming weight. So with example 1, we have n, which is a representation of bits. And as you can see, the number of 1 bits is equal to 3. So we have this bit representation here of zeros and ones, and we want to return the amount of ones we find in here. So we can clearly see that there are 3, so we're going to be returning 3. But how do we do this? And more specifically, how do we do this in a one-time complexity? So we have ones, and when we look at bits, we always look at the least significant bit first. So how can we determine whether this one right here is equal to a 1? Well, if we use the AND operator and we compare it to a 1, so we grab this bit, put it on this side, we compare it to a 1, this is always going to return 1. If we had 0, so in the case of this 0, we compared it to 1, this is going to provide us with 0. So we could have a global count variable, which starts off at 0. And if we compare this with 1, and we get a 1, we can increment this count to 1. So we've incremented the count to 1, and we need to move this pointer, right? So we need to look at the next bit within the sequence, and how we do that. So we have 0, 1, 0, 1, 1. So if we shift right by 1, we will get 0, 1, 0, 1. And then the least significant bit is now at the correct position. And then we can repeat the process. So we look at this 1, we compare it to 1, we have a 1. If we have a 1, we increment count, and then we shift right again. So now we're at this bit. We compare to 1, we have a 0, so we don't increment count. We shift right, we get to this bit. So this is now the least significant bit. We compare with 1, we have 1, we increment count, and then we shift right. So now we're at this bit. Now n is equal to 0, and if we're using a while loop, we can exit this when n is equal to 0. And time complexity for this is going to be O of 1, and space is also O of 1. Okay, so let's code this out. So if we set count to equal 0, and we create a while loop, so while n doesn't equal 0, we'll declare a variable to keep this simple, so it is 1, and we'll add the AND operator. So we're comparing n, the least significant bit, with 1, and if they're both the same, then we have found a 1, and we can increment count. Now what we need to do is shift right, so n shift right 1. And then finally, we can return count. So this will run through, it'll look at the first bit, or the least significant bit, it'll check if it's equal to 1. If it is, we'll increment count, so we increment count to 1, we shift right, so we look at this bit, it's equal to 1, so we increment count and we shift right. Then we look at this bit, it's equal to 0, so we don't increment count, but we shift right. Look at this bit, increment count, shift right. And now n is equal to 0. So we exit this while loop and we return the count. Let's give this a run. Submit it. And there you go.